Find the limit as x approaches 2 of x squared minus 4 over x minus 2. You know that if I were to just take 2 and plug it in, I'd get 0 over 0, and that's problematic. But what we also see is upstairs, you have a difference of squares. So if I were to factor the difference of squares out, that gets me x plus 2, x minus 2 over x minus 2. The x minus 2's cancel. Drop down the limit as x approaches 2 of x plus 2, and now you're good to go. Plug in 2, you get 2 plus 2 equals 4, and there's your guy. So what happened is you had a hole in this problem, and at the hole it's undefined if at that moment 2, but the hole exists at 4. So once we did a little bit of factoring and we found that out, we're good to go because the left and the right side match up. Everything is okay. You just do a little bit of factoring and you're fine. F of x equals this piecewise function. Okay, my job is to make sure I find out the limit as x approaches -1. Now, looks like my piecewise function splits here at -1, but this is what I have to keep in mind. I'm not going to just plug in -1 and plug it into this guy right here thinking, oh, it's or equal to, it's fine. This is an idea of we have a piecewise function and something like this could happen. Okay, and if we're trying to find the limit as x approaches a number, we need to make sure that the left side and the right side are exactly the same. And I don't know if that's the case yet. So what I have to do is I have to plug in -1 for both of these and see if I get the same number. If I do, then that means the left side and the right side actually approach the same thing, so something like this happens. And if that's the case, then I have an answer. If they don't approach the same thing, the limit does not exist. But if they do approach the same thing, it does exist, and it exists at the number that I get. So what I'm going to do is I'm going to do this first equation. I'm going to plug in -1. So ln of -1 plus 2 is the same thing as ln of 1, and ln of 1 is 0. Okay, the ln or the log of 1 is always going to be 0 no matter what log it is. It's just the way that exponents work because, you know, that's just the way exponents work. So you get 0. So this guy gave you 0. Let's see what this guy is going to give you. So if I were to plug in -1, I would have -1 cubed plus 2 times -1 squared minus 5 times -1. -1 cubed is -1. -1 squared is +1 plus 2, or times 2 rather, so 1 times 2 is plus 2, and then minus 5 times -1 is going to be plus 5. -1 plus 2 plus 5 is not 0. In fact, it's 6. So since these guys are different numbers, we have one of these right here. So since the left-handed limit and the right-handed limit don't meet at the same place, then the limit at the regular number itself does not exist. Okay, so it was kind of a tricky problem, but you know, we did it. If a can't be 0, then evaluate the following limit. The limit as x approaches a, which can't be 0. All right, so we have up here what looks like difference of squares. So x minus a, x plus a. We have down here what looks like a unique brand of difference of squares. So that would be a squared minus x squared and a squared plus x squared. Now I can keep going with this. Okay, the top doesn't change. X minus a, x plus a, didn't change. Okay, a squared minus x squared continues factoring. So that's a minus x, a plus x, and then we have a squared plus x squared. Okay, you cross out. And if I wanted to, I can pull out a -1 out of the top and get a minus x over a minus x a squared plus x squared. These guys cross out. That leaves me with negative 1 over a squared plus x squared. Now if I take the limit as x approaches a, bring that negative out front of 1 over a squared plus x squared, that gets me negative 1 over a squared plus a squared, which is negative 1 over 2a squared. Very bizarre problem. Very bizarre problem. But yeah, that's how you would do it.